to today's lesson on conic sections. We are going to be going over the topics in the Standard 2.4 and then also under the topics in the Study Island lesson called Conic Sections. This is going to be the part 2 of 2 videos where we talk about all of those topics that we just discussed. So if you're working on any of those things, make sure you watch both of them so that you are able to get the most information that you need to be successful. In today's lesson, we're going to be talking mainly about ellipses, hyperbolas, and circles. And so if you have questions about the other conic sections, make sure you watch the first video also. So I'm so glad that you're here, and let's go ahead and take some notes.
The first conic section we're going to look at closely is the circle. So when the circle is at the center, is at the origin, your equation is going to be x squared plus y squared equals the radius of that circle squared. And remember, the radius is from the center to the outside and the length of that. And so now, if the center is not, then you have a center where we're going to call the center HK, where H is the x coordinate of the center and K is the y coordinate of the center. You're going to have x minus that H number in parentheses squared, y minus that K number in parentheses squared equal to the radius squared. So this problem here, they're asking us to match the graph to one of these equations. And first thing I'm going to look at is what is the coordinates of that center. The coordinates of this center is going to be 0 through positive 3. So that means that since the x coordinate is 0, subtracting 0 on the x variable doesn't matter. So that's why there's just x squareds here. But the y coordinate is 3. So that means I'm going to have a y minus 3 as part of my equation. And so that's going to roll out b. The next thing I'm going to look at is how long is my radius here. My radius is 1, 2, 3 units. So this is going to equal my radius squared. So 3 squared is positive 9. So that can't be D. And then so I'm looking at A and C here, and the only difference between them is I have a plus here and a minus here. And since it's a circle, this has to be a plus. So it can't be C. My answer is going to be A. This problem here says you have a point 77 that lies on a circle, and then that same circle has a center of 2, 7. And it wants us to create the equation. So I've gone ahead and put a piece of graph paper into this problem. I added this in to help us out, to help us see it. And so you could always use a piece of graph paper on your EOI or as you're working these problems also. So this problem has a circle with the center at 2, 7, which is right here. That's my center. And it also has a point at 7, 7. So that's on the outside of the circle. So my circle, something like that. It's a pretty rough circle. But what we just use these 2 points for is to see how long that radius is. So my radius is going to be 1, 2, 3, 4, 5. And so my radius is 5 units long. And so that means when I go to write this equation, I'm going to have x minus my x coordinate of this center, which is 2, 7. So this is going to be x minus 2 squared plus, because it's always a circle, it always is plus there, y minus 7, because that's my y coordinate in my center. So I subtract my y coordinate, equals my radius, which is 5 squared. 5 squared is 25. So that means that my final answer is going to be B. The next conic section we're going to take a closer look at is an ellipse. An ellipse is basically what you called an oval in elementary school. And your ellipse can be longer horizontally or it can be longer vertically. And we have some different parts to an ellipse. So we have a major axis, and that's the long ways across here. And we have a minor axis, which is the short ways. So our major axis and a vertical one goes vertically, and then the minor axis is here. And so in order to find the length of the major and minor axis, that's where we're going to be looking in the denominator of our equations. So remember, the ellipse equation has both variables squared. It has addition between the fractions. It has fractions. And then it also has the lengths of our two axes in the bottom. So we use A for the major axis. So when the bigger number is underneath the x, that means that the major axis is going parallel to the x-axis, so it's a horizontal ellipse. When the bigger number is underneath the y-coordinate, that means that the major axis is going parallel to the y-axis, and it's a vertical ellipse. Now, in order to find the measure of the axis, it's going to be half of the axis is what we call the A and the B. So from this vertex to the center of the ellipse, that's one length of A. So to go all the way across, you're going to double A. However, in the equation, A is squared. So it's important to keep track of where the number is squared and when you need to double it. And the same with the B, the shorter way, the minor axis. It's the one length of B is from the co-vertex to the center of the ellipse. So to go all the way across, you have to double B, but to put the B, the right number, in the denominator of the fraction here, you have to square it. So that's the important thing to keep track of here. And then just like the circle, the center point is what's being subtracted here in the parentheses. This question here asks us to match this equation to this graph. But the tricky part here is that that this equation is in standard form. So we need to rewrite it so that it has the fractions in the parentheses so that we can easily see which piece is matched to which graph. So in order to do this, that means I'm going to have to complete the square for the x terms and complete the square for the y terms. So my first step is going to be to just rearrange this equation so that my x terms are beside each other and so that my y terms are beside each other. And because I know I'm going to be completing the square, I'm going to leave some blanks here just to help me see where I might need to fill in numbers. So my first step in completing the square is to see if I can factor out anything from the two x terms. They have a 9 in common, so I'm going to factor out a 9, and that leaves me with x squared minus 2x in parentheses, and I'm going to leave a space to fill in my completing the square number. And then my y terms, though, there's nothing there that I can fill in or that I can factor out, so they just stay y squared plus 4y. And once again, I'm going to leave a space for them too. So in order to complete the square with my x's here, I have to take my middle term coefficient, which is -2, and I'm going to divide that by 2, which is -1, and then I square that number. So -1 squared is a +1. So I'm adding a 1 there. And remember, whatever I add here, I have to subtract here so that I keep the equation balanced. So I added a 1 here that's being multiplied by a 9. So I'm really adding in 1 times 9, which is 9. So I'm going to subtract 9 at the end. And then I'm going to do the same thing with my 4 here. That should have a y next to it. And so I'm going to take 4 and divide that by 2. and that equals 2. And I square that number, and that gives me 4, so I'm adding a 4 here. This 4 isn't being multiplied by anything, so I'm just adding 4, so that means I'm going to subtract 4 at the end to keep the equation balanced. And so now I'm just going to have this 9, and I'm going to factor the x squared minus 2x plus 1 into x minus 1 parentheses squared plus, and then I'm going to factor the y part into y plus 2 parentheses squared, and then 4 minus 9 minus 4 is a minus 9 equals 0. So now, though, I want to move this 9 to the other side, so I'm going to add 9 to both sides. And when I do that, it's just going to be equal to positive 9. And so we're getting closer to that ellipse equation form that makes it easiest for us to match the graph. The next thing we do is we don't want any coefficients in front of our parentheses. So we need to, this 9 is times the parentheses. So to move it, we're going to divide every term by 9. And here's these cancel, and I'm just left with an 1 in the denominator, plus, and I don't have anything that cancels with the y, so this just all stays the same, equals 9 divided by 9 is 1. And now I'm finally have it in that form where I can start to match the graph. So the first thing is that my center is going to be positive 1, negative 2. My x-coordinate that's being subtracted here is 1. And then remember, when this is a plus, it has to change to a minus to get my y-coordinate. So my center here is 1, negative 2. So I'm going to look for the graphs that have a center of 1, negative 2. So 1, negative 2 is right here, so it's not the center of W. 1, negative 2 is right here, so it could be X. 1, negative 2 is right here, so it can't be Y. 1, negative 2 is right there, so it could be Z. So looking at X and Z, one is horizontal and one is vertical. My bigger number is underneath Y, so that means that the major axis is going to be parallel to the y-axis, which means it's going to be longer going vertically, longer going up and down, which is what X is. So my final answer here is going to be D. This problem is asking us to write an equation of an ellipse, knowing that it has a center at the origin, a major axis length of 16 units along the x-axis, and a minor axis length of 8 units, which would be with the y-axis, since the other one's the x-axis. So remember that we need to get the A number and the B number, and the A number is half of the major axis, so half of 16 is 8, and the B number is half of the minor axis, so half of the minor axis here is 4. And then we square these numbers to get the numbers that go in the denominator of our equation. So 8 squared is 64. 4 squared is 16. And so because the 64 is the bigger number, that's going to be my major axis, and the major axis is along the x-axis, so that's going to have the x squared above it. And that leaves the 16 to have the y squared above it. So looking at here, that means that A could be my answer, B couldn't be my answer because it has the wrong number under x squared, C has the wrong number under x squared, and D has the wrong number under x squared. So my final answer is going to be A. The last conic section we're going to look closely at is the hyperbola. And the hyperbola is two u's, either both one of them going left and the other going right, or one going up and one going down. And the equation for the hyperbola is you have two fractions, but now they're going to be subtracted by each other. And just like the circle and the ellipse, the center is going to be the coordinates that are being subtracted by the x and the y here. That's going to give you your center point. And now you're going to have what's called a transverse axis and a conjugate axis, and those are our a and b numbers. So if you look, our a number is our transverse axis, and that's how far it is, and a length is how far it is from the vertex to this point here. That's that we call the center. And so 2a is what it is from vertex to vertex, is if you double that a. And when you square that a, that's the number that goes in the denominator. So if you look, the transverse axis is underneath the x variable when it's a horizontal hyperbola, and that a squared transverse axis number is under the y term when it's a vertical hyperbola. So that's one way to tell if it's a vertical or horizontal hyperbola. And so then you have what's called the conjugate axis. The conjugate axis is what's created from these asymptotes here, and then when you draw this rectangle in. So you just need to know that that hyperbola, or the conjugate axis of the hyperbola, is what goes perpendicular to that transverse axis, and it's what's shown here by the b's. So here it wants us to write the equation of a hyperbola that has a center at the origin, a transverse axis length of 16 units along the x-axis, and a conjugate axis length of 12 units. So the first thing I'm going to do is find my a and b number. And so remember, a is half of the length of the transverse axis. So half of 16 is 8. And my b is half of the length of the conjugate axis, which half of 12 is 6. So because the transverse axis is along the x-axis, that means I'm going to have the x squared on the top of that, and that leaves the y squared to be on the top of 6. But the last thing we need to remember is that we have to square the a number in the denominator and square the b number in the denominator for our hyperbola equation. So that means I'm going to have x squared over 64 as part of my equation, and I'm going to have y squared over 36 as part of my equation. And because my center is at the origin, I'm not going to have any numbers being added and subtracted with my x's and my y's in the numerator. So that means the only place that has x squared over 64 minus y squared over 36 is a. This question here gives us the graph, and they want us to find which equation matches this graph that they give us. Well, the first thing we're going to do is find the center. And remember, the center is the point between the two vertexes in a hyperbola. So my center point there is where that blue point is, and the coordinates of that is -3, +2. So that means that in my numerators, I'm going to have an x plus 3 quantity squared because it's opposite. And then I'm going to have a y minus 2 quantity squared. And then and then this always equals 1. And then I have to figure out what it is I need to put in the denominator here. But just knowing that part of it with the centers is going to eliminate a and d as choices. So because this parabola is opening left and right, I knew that its transverse axis is horizontal and going the same way as the x-axis, so I knew to put my x coordinate first. And that means that that transverse axis, its length from the center to a vertex is 1, 2, 3. So that means that that 3 squared is what's going to go underneath my x term. And the one that has a 3 squared underneath the x term is b. So that makes b my final answer. So thank you for joining us today, and I hope you learned something new.